Um, I'm Hannah and this is my reaction to my video over chapter 7, nuclear energy. This chapter is basically about atomic nuclei and the roles of neutrons and nuclear fission reactions that can result in energy. We learn how important that coolants are and moderators, and we'll talk about those more later. And we learn about potentials of uranium and safety efforts. We deepen our knowledge about nuclear energy and how it's more clean than fossil fuels, but the growth of it is very slow. Depending on the state, just depends where you are. Some support zero emission credits and some don't, and there is potential for nuclear fusion, even though there are obvious challenges that there will be in anything that we go at. But this brings me to my first diagram, which is I thought it describes the whole chapter, and it just shows like all the different states in the United States that are more nuclear dependent, and some of the countries that are more nuclear dependent. The top three nuclear dependent states in the United States are New Hampshire, South Carolina, and Illinois. And then the top three countries is France, Hungary, and Belgium. We're actually like right in the middle of all of these countries of who are more like nuclear dependent. So we're per se more 50-50. Um, I just like the diagram because I thought it would be important for the section. This section is talking about atomic nucleus and like the discovery of nuclei and how like the fundamentals control interactions here in the universe and how we understand things. And we also touch bases with electromagnetism and in energy interactions and just like nuclear force. Rutherford's experiments is actually what led us to discover the nucleus, and we learned that it's made up of protons and neutrons, and these things determine like chemical properties of elements. The nuclear force and magnetism is what actually controls the energy interactions in the universe. Next, we talk about radioactivity. This one just talks about how like neutrons is what stabilizes atomic nuclei and other types of radioactive matter. If there's actually like these nuclei can become unstable, just depends. How we understand these things is very important because of this is what like can affect our health and the environment. Neutrons are actually the glue that hold together the nuclei, and like elements with atomic numbers that are 84 or greater are classified as radioactive and can cause alpha decay. And then another type of decay is called beta decay, which is when there's too many neutrons in a nucleus, which makes it unstable. Next section is energy from the nucleus, and this one just basically talks about like curve of binding energy and how it's just binding per nucleon um, and atomic number. Iron actually has the highest binding energy, just meaning energy per nucleon, just meaning that it's more stable. And then we learn about like the lighter the nuclei and the heavier the lighter it releases energy through fusion, and the heavier it is, it will release energy through fission. Which brings me to this diagram, and I liked this diagram because it really showed exactly how the curve actually works, and I liked how it used the arrows to indicate how fusion and fission are actually going like basically like right at each other. And I just thought it would be helpful, and it helped me to visualize it better. This next section is nuclear fission. In this one, we talk about how like this can cause like significant heat, and it needs to be managed to help reduce disasters, but it can also be used to produce energy. We learn about coolant, how important coolants are, which is how we like take this heat away from these things. And helps us just control it better. Energy is actually released during this process when it splits a massive nuclei. And it's actually uranium-235, which is a key isotope in nature. Nuclear fission is when you form two nuclei and it processes kinetic energy, and it can produce radioactive products. This was very huge in our history because of Enrico Fermi and some of his other colleagues, which helped to bring us to radioactive materials. And like this is of course like how we get to how we are today. Without these things, it would be impossible. Basically, our modern times wouldn't be the same. I'll put it that way. Then we talk about nuclear reactors and how they can sustain a fission chain and produce energy. Components of these are different. Like it could be like fuel rods, coolants, moderators, control rods, things of that nature. And there's actually two types of light water reactors, which is the most common use in the United States, which is BWRs, which is boiling water reactors, and PWRs, which is pressurized water reactors. And the most safe one has the most advantages is the PWRs because, like I said, because of the safety benefits, which brings me to my third and fourth diagrams. The first one, it shows us like an inside of a hot water reactor, and it just shows really like how the control rods go up and down to control like pressure and stuff, and it just shows how it works in simpler terms. And this next diagram talks about the nuclear fuel cycle, and it just really breaks down into things like what we really need to know. It goes all the way from the mining aspect up to like when it's in the nuclear reactor, all the way back down to the underground repositories. The next section, it talks about the nuclear fuel cycle, like this diagram that we just looked at. And it just talks about like the cost of uranium and how it can sustain for a long time. And like the potentials that we have to take these to get this kind of energy from like oceans and like large portion like places that can make it long term. The cost of uranium is actually has a really small impact on the nuclear energy as a whole, like compared to fossil plants. But it is less effective because of the fluctuations it has in the cost. Because so that means like we never really know how much it could be or how little it could be. And it's just important that we find alternatives that are more clean than fossil fuels because of our climate crisis. And therefore, nuclear energy can be a very effective way. Environmental and health impacts, of course, nuclear energy is going to have different impacts. Everything that we have has different impacts depending on what it is. And in this one, it just talks about how it's just like trying to ensure safety and how to reuse these materials and make it into something more useful. One of the programs are called megatons to megawatts, and it just basically converted Russian nuclear warheads into reactor fuel. Actually, 10% of the U.S.'s electricity comes from recycled bomb fuel from the 21st century. And then in 2017, the International Nuclear Fuel Bank was actually established, which is huge because it just helps the nuclear industry. Then we talk about like if there's a future for nuclear energy, and it is less harmful for our environment compared to fossil fuels, which is our most dependent source of energy. But it is very slow, and it's very unlikely that it's going to replace fossil fuels anytime soon. It's because of like Asian plants, development times are much longer for new reactors and different challenges in the economy. Nuclear power is actually growing in countries like Asia because they have a really high energy demand, and nuclear energy could help us to address climate change. Then we get to one of the little boxes of the science states policies. And this one just talks about like emission credits for nuclear power, and it talks about how some of the states in the United States actually support some of the older reactors, which has like the zero emission credits, and it just basically helps to encourage lower carbon emissions. And of course, policies are going to change because of the support of these things. And like in the nuclear industry, and some of the states that support these and encourage lower carbon emissions are like New York, Illinois, New Jersey, Connecticut, and Ohio. This is also called ZECs. But these policies so far have withheld in court, even though they have went through various different challenges, like anything's going to. Then finally, we talk about nuclear fusion, and this one just talks about how like there's potential for nuclear energy, even though there are challenges that we're going to face if we were to use it as if it became more of a dependent source of energy in our future. And it just talks about like how nuclear fission is more mature, and it can be limitless, and it could be like it of course already goes into our energy supply here in the United States, but it could be limitless, whereas fossil fuels will run out. And finally, fusion reactions create things like iron, and it actually helps. It's what like helps create stars and planets and other elements like in our bodies and our planet. And I had no clue that this is what like went into our making stars in our bodies and stuff. But I learned a lot of new things in this chapter about like different words that I had never heard before. And it just really made me more knowledgeable on this subject and of nuclear energy. I didn't even know that was really one of the factors that could have been an energy source for the United States. It's very interesting to learn about, and I'm glad that I got to. So thank you.